Today we're going to talk about lesson 7.2, where we're dividing and multiplying radicals. We've already seen how to simplify them in lesson 7.1, and all those rules for simplifying still hold. But the new question is, if I give you a radical that has the same index right here in front, and another radical with the same index, then we can say that it's radical A times radical B, which is the same as putting both A and B together under the same radical. In fact, we actually saw this yesterday, kind of going backwards. You saw about splitting up numbers and thinking about the root of one and then the root of the other. So an example of something like this would be if I have the cubed root of 8 times the cubed root of 4, then we can think about these together being the cubed root of 8 times 4, which is the cubed root of 32. And then we want to think about how do I simplify the cubed root of 32, ... So let's look at an example here. Multiply and simplify if possible. Now, it's a square root and a square root, which means we can put them together, and under the same square root, that would be 3 times 12. Or, that's the same as root 36, and root 36 is a perfect square root. We'll just say the answer is 6. Here's another one, cubed root times cubed root. So we say this is the cubed root of negative 16 times 4. Negative 16 times 4 is negative 64. You should have your squares and your cubes handy because we know that the cubed root of 64 is a 4 and it's a negative, so it will be negative 4. Again, a thought bubble for us here. Remember that what we're saying is that it's the cubed root of negative 4 times negative 4 times negative 4. 3 negatives will make it a negative 64, and they're all the same, so it just simply comes out as a negative 4 here. Now, if we have square root negative 4 times square root 16, we'll end up getting negative 4 times 16, which is the square root of negative 64. But since this is a square root, remember we're not allowed to have negatives under the square unless we pull out an I to go with it. So this reviews what we saw yesterday, that when you have negatives under a cubed root, the answer can come out negative, but negatives under a square root must come out with this I here in your answer. Now, if you have a square root times a cubed root, as we do here, we say not possible. Remember, the indexes, or the indices, must be the same. All right, let's go back to reviewing a little bit when we have the variables in our answers as well. So square root 50 x to the 5th, remember that we just want to break this up into all the perfect pieces. So this would be 25 times 2 times x to the 4th times x. Perfect pieces get to come out, so we have 5x squared 2x. Cubed root of 54 would be 27 times 2, and it's n to the 8th, so we could get n to the 6th. 6 is divisible by 3, and then a leftover n to the 2. Perfects. So 3n squared, and then the cubed root of 2n squared. Again, please remember to keep this cubed throughout your work there. All right, 72. 72, I'm not sure what factors of 72 are, so I'm going to try, let's see, 72 is divisible into 2 times 36. There we go. So 36 times 2, x squared and x. So we get 6x root 2x. Cubed root here of 16n to the 20th would be 8 times 2. 8 is a perfect cubed. And then n to the 18th is divisible by 3, leaving us with n squared left over. So 2n to the 6th cubed root 2n squared. All right. Now again, what we just did here was actually kind of the reverse of the multiplying. We thought about one number, broke it up into different factors, and then separated them. So let's think about multiplying when we have all these different pieces together. A couple of things. If you have numbers in the front, as we do here, where we have a 3 on the outside and a 2 on an outside that are not part of our square root, they are going to just sit together on the outside while we deal with the square root. So 3 times 2 is just going to sit here. And then it is a square root and a square root, so these can all come together. 7 times 21. And then we have an x cubed, an x fifth, and a y third. So we will have 6. 7 times 21 will be 147. I think so. 147, yep. 147. And then we have x to the 8th and y to the 3rd. And we want to think about what can we do with this 147. Well, let's see. This could actually be 49 times 3. X to the 8th is perfect. He'll come out just fine. And then a y squared and a y. So we end up getting 6 times 7, x to the 4th, y, square root 3y. And simplifying this gives us 42, x to the 4th, y, square root 3y. All right, one more example here for multiplication. They're both cubed roots, so it is okay to multiply. 4 stays out in front. 25 times 5 is 125. X and x to the 4th would be x to the 5th. Y 8th and y to the 3rd would be y to the 11th. Break it up. We know that 125 is perfect, so that'll be fine. X to the 3rd and x to the 2nd. And y to the 9th and y to the 2nd. So we have 4 times 5 x, y to the 3rd, cubed root of x squared, y squared, which is 20, x, y to the 3rd, cubed root, x squared, y squared. So that's the multiplication, okay, putting pieces together when they have the same radical. We also have dividing radicals, and this is actually the same idea. We say that as long as they have the same index out in front, then we can say the square root or the cubed root of a divided by cubed root of b, and this can also be written as one large radical of a over b, and then again we simplify dot 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 dot. So for example, for our first one here, we have the square root of 243 and 27, and we can rewrite this as a single radical because they are both square roots. So this is really 243 divided by 27 in the same radical. When we divide 243 by 27, we end up getting 9, and we know that the square root of 9 is just 3. Write this one in the same radical here. We have 12 divided by 3, which is 4, and x to the 4th divided by x would just be x cubed. So this becomes 4x squared x. Perfects come out, so 2x root x. Let's look at some example with cubed roots. Because they're both cubed roots here, it's okay. So we can say this is the cubed root of everything, so 192. X to the 8th all over 3x, and 192 divided by 3 is 64. So the cubed root of 64 divided by x to the 7th, and then this could be the cubed root of 64x 6x, so 4x squared cubed root x. Now, when we have this one, we run into the problem. See, there's a cubed root, but then this is a squared. So it's not possible. They have to be matching roots in order to do it. We'll talk about rationalizing the denominator in our next video.